Alright, sorry guys, there's still a little bit of feedback noise. I'm not exactly sure why. I tried to troubleshoot, but I wasn't able to fix it. So, I'm going to verbally give you the directions for your quick check today, and it'll be the same directions for tomorrow. To start off, you should all be in your testing seats, which means seat numbers 2 and 3. One person needs to move so that no one's side by side, and you should have your manila testing dividers. So for quick check number 1, you are going to sit in your testing seats. You're going to use a pencil, no calculator, and you'll have 15 minutes to complete the quiz. If you finish the quiz early, you can go to the back of the classroom. You're going to leave your pencil at your desk. One more time, when you are done, you will leave your pencil at your desk, and you'll go over to Miss Vale's room through the back door. There will be copies of the answer keys there, and you'll be able to check through your answers. You can write on your test, but you can only write with the colored pens or pencils. So you're essentially checking your answers, correcting mistakes if you'd like. When you're all done taking a look at the answer key, you will then give your quiz to Miss Stedman and go back to your seats. In terms of checking your answers, if you guys could please put a check mark if you believe your answer is correct, and then if you get the answer wrong, you can exit out, and you can also write whatever information you need to help you next to your answer. There should be no erasing because these are actually going to be graded. So at this point, Ms. Stedman, can you please pass out the quizzes if they already do not have them, and let them start taking the quiz. You have 15 minutes, and again, when you're done, put down your pencil, go through the back door to Miss Vale's room, and you will check your answers. Ms. Stedman, please press pause. Alright, at this point you should be finished your quiz. Ms. Stedman, you would have collected all of the quizzes from them. It should be about 15 minutes. We're going to go through and do a homework check. So one of you please go over to the side and get the yellow homework slips. You are checking for homework number 2, which was a book assignment. So you give yourselves 10 points for doing, 5 points for checking. At this point, if you have homework questions, please use this time in groups to ask questions. And then if you still have questions, Ms. Stedman will go through and answer a few. She'll take about 5 minutes of questions. Ms. Stedman, please press pause. At this point, homework questions should be done, and we're going to move into the last problem from yesterday's notes. We didn't get to finish it. Period 5, I don't think you even started the question, so I'm going to start from the beginning. So, it is to find the extreme values of this function, and I'm going to use your 5-step process, and remember, you don't necessarily have to go in this order, but it does ensure that you don't forget anything. So to start off one more time, the first thing we're going to look up is the domain. Alright, so we have a square root and we have a fraction. So I'm going to take the denominator of the fraction, set it equal to 0. If you square both sides, you actually get that x squared is equal to 4. So x is equal to plus or minus 2. And so, here's plus or minus 2. We're substituting this into that piece right there. So, if I substitute in 0, we get positive. If I substitute in positive infinity or negative infinity, it would cause the x squared to be too big and it'd be negative. So what you're asking yourself is, if the value under the square root was to be 0, would that be okay? And it would not, because it's at the bottom of a fraction. We also know that square roots do not take negative values, but they do take positive values. So your domain for this problem is negative 2 to 2, open. So the second question you would ask yourself, are there endpoints? And in this case, no, there are not. I know you kind of feel like there might be, but because they're not closed, There's no endpoint, so not closed. So remember, this is where you just ask yourself real quickly, does EVT hold? EVT does not hold because of the endpoint. It's not a closed interval. Alright, so at this point we're going to find the derivative. And I'm actually going to go to the next page. I'm going to rewrite the problem. Square root of 4 minus x squared. So you have the option of doing the quotient rule, but again, I would not. I would rewrite this as 4 minus x squared to the negative 1/2 power. So, remember to label your work. At this point, we're doing step 3 in the process. I'm finding the derivative and simplifying it completely. So, go ahead and take a second to try to find the derivative and simplify it completely at your tables. Ms. Stemmen, go ahead and just pause it for a moment and let them work for about 2 minutes. See how far they can get. Alright, so even if you're not done, let's go over the derivative. Because of the way I changed the problem, I'm just doing a simple chain rule. So, derivative of the outside would be drop the power down. And then that would be to the negative 3/2 power. The inside would be 4 minus x squared. And then remember your last step a lot of you guys forget about, multiply by the derivative of the inside. So there's pretty much the pieces of the derivative, but we do need to simplify. So if I was to simplify, I see that I have a 2 here and a 2 here. They'll cancel. I have a negative times a negative, which will turn into a positive. And then in the numerator, I believe I have an x, but the denominator, I end up with 4 minus x squared, see, to the 3/2 power. And then you just want to double check. We could potentially factor the denominator also. So there are the factors. But even though it's factored, it's still within the 3/2 power. Alright, so I would take either of those two answers just because we are within the 3/2 power in terms of simplifying completely. I do enjoy the factored version a little bit better because from there we'll be able to see real easily, sorry guys, we'll be able to see real easily where the derivative is equal to 0 and where the derivative is equal to undefined. So remember, we write down both. So we're going to start off with the 0. That would be setting the numerator equal to 0. This is why you want one complete fraction. You don't want two fractions because of the fact that it's really difficult to do this part of the process. And then we want to set the denominator equal to 0, which would give us the undefined. So 2 minus x, 2 plus x, to the 3/2, set it equal to 0. I would I would take both sides to the 2/3 power, and that will eliminate this power here. So really I end up with 2 minus x times 2 plus x equals 0. So x is equal to plus or minus 2. That should make sense because remember when we were doing our domain, there were open circles at 2 and negative 2. Therefore, the derivative must be undefined there. Alright, so step 4 of our process. We want to make our sign chart. And we have from negative 2 to positive 2. Please label your sign chart. I'm doing the sign chart for f prime. We're undefined here, we're undefined here, and remember they were not part of the domain. So we're crossing these out so we don't get confused. It means in your answers you better not use that as a max or a min. And then at x equal to 0, the derivative was 0. So I'm going to substitute in values. Now, This is where understanding functions really is helpful. So I'm going to highlight the function right here. And because of this even root, that's what this 2 is. Hopefully you guys can see the green. Because it's an even root, remember, that whole denominator has to be positive, because if for some reason it was going to be negative, we wouldn't be able to substitute a value into an even root that's negative. So we can essentially do our sign chart based off of the numerator piece. That's this x. The reason I can do that again is because the denominator, because of the even root, the whole entire denominator is within the even root. Therefore, the whole entire denominator is always positive. So I'm really only looking at x. And if I put -1 into x, it'd be negative. If I put +1 into x, it'd be positive. There's our sign chart. And step 5 would be to do our table. But if you remember, there are no absolute max or mins guaranteed because EVT didn't hold. So at this point, the only thing I have here is a min. The function goes, and I'll do this in green too, function goes down, flat, and up. And it goes to open circles, so I'm actually going to put open circles on my graph for you so you can kind of see. There is absolutely no possible way that this isn't an absolute min, so it does help to know that. So there is actually an absolute min at x equal to 0 because f prime of 0 is equal to 0 and f prime changes from negative to positive. The reason why I didn't do a XY chart for step 5 is because we're not guaranteed absolute max and min, so I don't really need to find if there's an absolute min or an absolute max. Alright, so that was the last problem from yesterday that I wanted to go through, just a little more practice. Today's practice is actually a bunch of multiple choice questions. I don't actually know how many you're going to get through in class, so what I'm going to do is complete the key for you on this video. So if for some reason we don't finish all of them in class, you can look at them in your own time. Alright, so here's your first multiple choice. It says on the top, I want you to work in groups. Work on number 1 and then come to a consensus answer. So, Ms. Stemmen, if you give them a little bit of time to go ahead and get started, walk around and just see how far they get for this problem. Watch your time. I would like to get through maybe 2 in class. There's a total of 4. And please press pause as they're working. Alright, so this one is a little bit tricky, and that's pretty much each of these. I wanted to show you how we could do a max-min problem that might be a little bit harder than just doing the 5-step process. And in this case, this is a little bit odd because of what they're trying to ask you to maximize. So what I mean by that is, normally we always find the maximum and minimums of f of x. Well, in this case, they're actually not asking you the max or min of f of x. They're asking you to find the max or min on f prime of x. So if you go through the process, you're actually going to need the derivative, and then I'll show you how we can easily do the 5-step process using the derivative. So to start off, this will give us 4/3 x cubed minus x to the 4th. In this case, we are going to actually find the max or mins of this function right here. So if this is what's going to confuse you, name it something else that doesn't have a prime. We're going to just call it g of x. And the derivative of f of x, we're going to call it g of x. So we're going to find the maximum on g of x. And on the left side, I'm still going to keep the prime so that you understand what's going on between the g and the f. So step 1 is to find the domain of the function. This is a polynomial. There's no square, even roots, there's no log, there's no denominator, all that good stuff. So the domain is all real numbers. And then step 2, there's no endpoints for this guy. So therefore, EVT does not hold. I'm just going to put EVT no. So since it doesn't hold, we're not guaranteed an absolute max or an absolute min, but there must be a maximum somewhere. So step 3 would be to find its derivative. And notice the way I said it, its derivative. So really, you're finding the second derivative. And that would be 4x squared minus 4x cubed. And that's the same as me saying, oh, given the function g, I'm going to find its derivative. So over on the right, you'll notice that this still follows our 5-step process. On the left, the difference is I'm not finding the max on f, I'm finding it on f prime, and that's why down here I needed to take one more derivative. In step 3, you need the derivative of the function you're finding the extrema for. And the function we're trying to find the extrema for happens to be named f prime. Alright, so I'm going to factor this guy. Oopsie. And then remember, that's still g primed of x, or we can also call it f double prime. I'm going to take f double prime and set it equal to 0. I'm going to take f double prime and set it equal to undefined. Remember, if that's confusing, you could use g. So I'm really doing g prime equal to 0 and g prime equal to undefined. So if I want this equal to 0, we're not going to have to worry about the undefineds because there are none. I would get that 4x equals 0 and 1 minus x equals 0. So I get x is equal to 0. I also get that x is equal to 1. And then step 4, your actual sign chart. I'm doing the sign chart for f double prime. The domain is all real numbers, so I have arrows at the end of my sign chart. The two values are 0 and 1, and they're both zeros in terms of f double prime. And then given the factored form, which is right here, that's what I'm going to use to make my sign chart. So if I put in 0.5, this would be positive, this would be positive. If I put in a million, they would be positive and negative. And then if I put in negative 1 million, that would be negative, and that would be positive, so this would be negative again. So the question was, where does it attain its max value? We're going down, flat, up, flat, down. So you can see where it attains a max value is at, be careful, at x equal to 1. And just double check what you're solving for. They wanted the x value, therefore the answer is C. Sometimes it's confusing because they'll ask you just for the value, the maximum value, and in that case we'd have to substitute back into the function we're maximizing. So in this case the answer is letter C because they asked us for the maximum. It's multiple choice, so you don't have to give a reason why it's the maximum. Alright, you're going to try number 2. Again, go ahead and pause and give the students a few minutes to work on it. I have no idea what time it is right now, if we've run out of time, but at this point I'm just going to do the answer key, and then if class is still running, Miss Stedman, if you could please just pause for each time you're going to give them, give the class a little time to work. Alright, so here's our function. We've got endpoints, so remember I talked about how to label your questions here on the AP. That's what we're going to look for. And then they want an absolute maximum. So if there's multiple maximums, they want the absolute. So I'm going to do my 5-step process. The domain, easy because it's a polynomial. All real numbers. Number 2, are there endpoints? Well, there are, 0 to 9. Therefore, because of these two things, EVT holds. And so we are 100% guaranteed that there is an absolute maximum. We're also guaranteed an absolute minimum. Alright, so step 3 of the process, we're going to find its derivative because the function we're maximizing is f of x, so we're going to find the derivative. Makes it a little easier here. X squared minus 8x plus 12. We're going to set the derivative equal to 0. We're going to set the derivative equal to undefined. Because it's polynomial, we don't have an issue with undefined derivatives. We are going to take the derivative. I'm going to actually factor it all the way up here, save a little space. So I should have x minus 2 and x minus 6. So if I want this equal to 0, the derivative equal to 0, I get x equal to 2 and x equal to 6. Step 4 is the sign chart. The sign chart's really important. The fact that we have endpoints, I really want you to make sure you're only doing a sign chart from 0 to 9. Put in your 2, put in your 6. Your derivative is 0 at 2 and 6. The derivative is nothing special at 0 or 9. Those are not critical values. And then we're going to do our sign chart. I'm going to do my sign chart one other way because we always do our signs. If you look at this, we know it's a parabola. And if I was to draw the parabola on this axis, because it's a parabola facing up with 2 zeros, that's really what it would look like. And as a result, I can easily do my signs. The graph of f prime is above the x-axis. The graph of f prime is below the x-axis. The graph of f prime is above the x-axis. So I'm essentially doing a chart of y values. If that's confusing or too difficult for you, then you will go through and you will pick a number between 0 and 2, pick a number between 2 and 6, pick a number between 6 and 9. There are 2 different ways that you could possibly do your sign chart. So in green, I'm going to start off at an endpoint that's closed. I'm going to go up, flat, down, flat, up, and put my point. You'll notice that there are 2 maximums. There's a maximum at 2, and then there's also a maximum at 9, which is usually the one people forget about. If you have a closed endpoint, those are also going to be maxes or mins. So at 9, I also have a max. So here's one where we have to do the step 5. So step 5 is I have 2 maximums. My maximums occur at 2 and 9. The function that we are maximizing, kind of a pain in the butt, is this guy. And so you're substituting 9 and 2 into that function. So given 2, this would be 8/3 minus 16 plus 24 minus 5. When you substitute in 9, this sucks. 9 cubed divided by 3, so 9 times 9 is 81. 81 times 3, this is exciting, 243. So 243 minus 9 times 9 is 81. 81 times 4 is going to be 324 plus 108 minus 5. Alright, so let's see. I think for this guy we get 8/3 plus 3, which would be 17/3, and then this one we end up with 22, which is definitely the larger of the 2 values. And so where the absolute maximum happens, it's going to occur at x equal to 9, and the value of it is positive 22. Number 3, again, pause if you need to. The first derivative of the function is given by this guy here. How many critical values do we have on the open interval? So what's tricky is they already gave you the derivative, and remember the definition of a critical value is that the derivative equals 0 or that the derivative equals undefined. I don't like the way that the derivative is given right now, so I'm actually going to just find a common denominator real quick. So taking this guy, the common denominator would be 5x, so I actually get 5 cosine squared x minus x all over 5x. So, saying the derivative equal to 0, I get 5 cosine squared x minus x equals 0. And this guy, I'm just realizing that this is probably a calculator question. F prime equals undefined. We get that 5x is equal to 0, so x definitely equals 0. Alright, so this is actually a calculator question, and I don't think I would have noticed that until trying to do the problem. So, Ms. Denman, could you actually go through and pull up the TI-84 calculator? I realize I don't have access to my TI calculator on here, but I'm going to actually go through what you would want to do, and I won't be able to show it to you, especially if you're at home, but I'll go through the steps. We already talked about if I want critical values, I want when f prime is equal to 0 and when f prime is equal to undefined. And actually, I'm going to keep what I had up just because that does help us a little bit. So we actually already know one critical value that's here. So really, this is the other piece that I'm trying to solve. You could do this whole entire problem with the calculator. What I mean by that is you would actually graph this guy right here, and then you would look for when this graph equals 0 and when this graph equals undefined. So what that looks like on a calculator would be x-intercepts, or wherever you have a discontinuity type, whether it be a removable discontinuity or maybe an infinite discontinuity. The fact that we did a little bit of work, it does make it easier. So personally, I probably would do this, and then this is what I would graph right here. So my y1 would be 5 cosine squared x minus x, and then you don't really need a y2. For this guy, you're going to look for zeros, and you're just going to count how many zeros there are, so how many times it crosses the x-axis. In terms of your window, I would do a window from 0 to 10, and because we only care about the x-axis, I would do probably -2 to 2, and just look at how many times we cross that x-axis. So I don't know the answer to this guy because I don't have my graphing calculator with me, but you guys can go through, and Ms. Stedman, if you could just announce the answer either if we have time today or tomorrow. Thanks. Number 4. Let's try to make this. Alright, so a point moves on the x-axis in such a way that its velocity. Alright, so here's my velocity function. At what value of t does v attain its maximum? So you'll notice that I'll start to do this. I haven't talked really about it, but I like to write what I'm looking for, and then I write who I'm trying to maximize. And the reason I do that, it makes you focus on what function you're going to find the domain for, what function you'll look for endpoints for, and etc. So for this guy, I'm going to maximize velocity, so that's the function I would need the domain for. And this guy, without having to do much work, you should know that the domain for ln of x is always x is greater than 0. And this tells us that x can't be 0, so the domain's already given up here. I'm just double checking that there's no discontinuity within that domain. So easily, we know that in terms of endpoints, there are none. Therefore, EVT doesn't hold. We're not guaranteed any max or mins. Or sorry, absolute max or absolute mins. But we're still going to go through the process. So if I'm trying to maximize velocity, then that's the function I need its derivative for. So I'm going to do this as, I guess I'll do it as a quotient rule. Low, d of high, minus high, d of low, all over low squared. So t and t will cancel. I end up with 1 minus ln of t all over t squared. I need to find where the derivative, oopsie, not step 4. need to find where the derivative is equal to 0 and where the derivative is equal to undefined. This one's your easier one. Denominator is equal to 0, so t is equal to 0. Remember, that's not part of the domain, so I'm going to end up crossing it out on my sign chart. F prime equal to 0 would be 1 minus ln of t equals 0. 1 is equal to ln of t. So I'm going to use e to cancel my ln, which means I got to do it on both sides. And I get t is equal to e. So, step 4 right here. I'm going to do my sign chart. And remember, we're going from 0 on. I'm doing the sign chart for v prime, so I do write that. Put 0 here. I put e here. I'm going to put an undefined for t equal to 0, and I'm going to put a 0 for when t equals e. And then I am going to cross out this guy. In terms of a value in between, I will pick 1. So 1 would go here, and here's where we're substituting into. The ln of 1, you do need to know that that's 0. So I get 1 over 1, which is positive, and take e squared would be an easy value to pick. So if I do e squared, remember the bottom's going to always be positive. So when I'm doing my sign chart, I can ignore this part. So I'm really only using the numerator. Just to show the work, I am going to put 1 minus ln of e squared. Remember, the 2 can come down. 2 ln of e, but ln of e cancels to 1. So you get 1 minus 2. So right here, this would be negative. So where does it attain its maximum? The maximum occurs at t equal to e. How do I know that? Because the sign of this goes up, flat, and down. So at t equal to e. Alright, so those are all your multiple choice questions. I'm sorry about number 3.